Hi, my name is Rana Bastawisy, and today we're going to talk to you about our project. Our project's aim is to help the blind people feel less paralyzed about themselves, help them feel the environment they live in, the colors around them, and help them have the sense of picking out the colors they're going to wear. Pick out the colors of their clothes and match them together. It also helps them to walk down the streets or in their own apartment freely without any help of others, without someone holding their hands, nor with a stick telling them if there is an obstacle in their way or not. Now my colleagues will be telling you how we implemented our projects. Thank you.
Hello everybody, my name is Mohamed, and now we are going to discuss the code for the Arduino board and its configuration with the inputs and output sensors. First of all, the obstacle configuration, and this is part of for the color configuration and light, and then the sound. Second, we'll go to the loop and check for every sensor how it works. So if the obstacle is low, which means that there is an obstacle in front of the infrared, so a sound will be passed to the metal to the wave shield, and it will produce a sound that tells us that there is an obstacle in front of the infrared. And if there is no obstacle, then a high signal will be passed to the input of the infrared, and a sound will be produced that tell us that there is no obstacle in front of the infrared. And here is the code for the light sensor, which also tells us that if there is a light in the room, then a signal will be sent to the wave shield that to play the video that tells us that there is a light in the room, and if not, another video will be played that another sound will be played that tell us that there is no light in the room. And here is the last part, which tells us that if for the color sensor, and many signals will be sent to the wave shield that tells us is reading. We check first for if the value of the red and green and blue, if it's smaller than 50, then the wave shield will play a sound that tells us that it's a black color. And if the red is greater than, and if the red and green and blue values are greater than 200, then another video will be played that tell us that is and so on with the other colors. And here is the code for the send, which sends the signals to the wave shield, and according to the signal sent, it will play a sound file. And here is the TCS, which responsible for the color sensor, and according to and it's always running and check for the color that our color sensor is standing in front of.
Hi, my name is Mariam Magdy, and now I'll be showing you how we connected our sensors to read the inputs to the Arduino board. First, we have here our color sensor. It has 7 connections. From S0 to S3, they're connected to the Arduino board. Pins from 3 till 6. And then we have the VCC, which is connected to the 5 volts on the Arduino board, and the ground is also connected to the ground of the Arduino board. We also have the out, which outputs the input to our code, and we connect it to pin number 2. Here we have our infrared sensor. It has 3 connections. The VCC is also connected to the 5 volts. We use the breadboard so that we can use it for both. And we have the ground, which is also connected to the ground here. And the output here, it outputs on pin number 7. Here, to sense whether we have light or not in the room, we use a LDR, a light dependent resistor. We also use another normal resistor so that the circuit acts as a voltage divider. So depending on the resistance of the LDR compared to the 10 ohms resistor, now we can read the input and decide whether there's room or not. We have them one side, one port of the LDR is connected to the 5 volts, and the other is connected to the resistor and the ground of the Arduino board. And we also have one side here connected to the A0 port, which is configured on in our code to read the input of the LDR. Thank you.
Now, Mariam told you about the inputs of our project. Now I'll be telling you more about the outputs of the project. For getting the output, the sound that the blind people will be hearing, it's used through the wave shield resistor. The wave shield resistor takes in a memory card that has all the inputs we will be needing for the user to listen through. Now the wave shield resistor is connected from ports from 8 to 13. It's also connected to the ground and to the vault. Here through this we can apply headphones, and we will be listening to the order to the right output that we need, depending on our sensors. Here we have a play and rewind and forward and forward. However, we will not be needing them as it.
Hello, my name is Karim Ismail. I will be running the code and try different cases to show you the different outputs the sensors are producing depending on the readings they are reading. So I will be uploading the code on the Arduino. First, we will be testing when there is an obstacle in front of the infrared sensor. So if we try to run here, it's printed here that there is an obstacle in front of the user, and play 7 means that the wave shield will be playing the audio, which is number 7 in our memory card, which will be telling the user that there is an obstacle in front of him. For example, if we started putting different colors in front of the color sensor, for example this is red color, we will be noticing that the red components are being increased and the green and blue are being decreased, which means that we have a read of red color. If we try the white color, all the components will be increasing, reaching 200 or more, which means that we have a white color. If we tried the black color, all components will be decreasing, having values less than 70 or something, which means that we have a black color. Each color we have 5 cases, one for red, blue, green, white and black, and for every case we tell the wave shield to play the audio file which corresponds to the specific color. To listen to the sound of the wave shield, we should connect the headphone jack, but unfortunately it won't be heard in this video. Here we will be testing the light dependent resistor. It's printed here that it has a value of 605, which means that it has a strong light intensity. If this reading is less than 100, it means that the room is dark, and we're gonna tell the user to turn on the light so that the color sensor can read the color it's being put in front of it. That's all. Thank you.